Good morning, everyone. Why is safety engineering so important in our day-to-day lives? Why should we be concerned with it? Well, the answer is actually pretty simple. It's because this can turn into this if the proper precautions are not taken. To me, engineering is much more than just being good with numbers. Engineering allows innovation to take shape by the development of transportation or communication technologies, for example. When combined with medicine and the medical sciences, engineering allows for the improvement of the quality of life and prolonging life. Engineering can also help us understand fundamental questions like, why are we here? How do we get here? But engineering can also help us stay safe. That last part is what's often referred to as safety engineering, and that's what I wanted to talk to you about today. Unfortunately, safety is not top of mind for a lot of people. We're just too busy with everything else. We tend to take things for granted. Luckily, there are people out there that are working towards keeping us safe. Safety engineers, in general, operate under the moral obligation to make the world a safer place. A world that's often dangerous because of the actions that we take. Before I keep talking about safety engineering, I want to give you a little bit more on my background and what led me down this path. I attended Wright College back in the late 90s. Wilbur Wright College is one of the 7 Chicago City colleges. To me, Wright College will always be near and dear to my heart. My father attended here, my uncle, my brother, we all ended up becoming engineers. I met a lot of great professors here, including Dr. Benito Callau, who was the one who convinced me to go into chemical engineering. Now, don't get me wrong, I'm not in love with organic chemistry, but I was good at it. And the way that I think about it is we're all made up of molecules anyway. So after I got my degree from here, I transferred over to the Illinois Institute of Technology, or IIT, completed my bachelor's in chemical engineering, eventually coming back a few years later to do my master's. My first job out of college was at the Gas Technology Institute, or GTI, where I was first exposed to what we refer to as the business environment, how to interact in the workplace, how to network with people, something that we often refer to as business maturity. So I stayed there 5 or 6 years. I learned a lot, specifically on combustion. That was my area of focus. But at the age of 27, I was getting an itch. I wanted to try something else. And I kept seeing this place off the Ames Expressway, thinking I'm an engineer, it's a lab. So I decided to check them out. After all, the logo that you see up there, UL, you tend to see it pretty much on everything in your house, whether it's on the back of your TV, on your fan, on the dishwasher, you name it, you usually see this. It's actually even on the fire extinguishers on the hallway. So I looked into them and I thought that what they did was interesting. So I applied and I got hired, and that was one of the best days of my life. It was at UL where I was first exposed to the concept of risk mitigation, safety, sustainability. And over time, those concepts became somewhat of a passion in my career, because those very concepts represent an effort at the preservation of human life and safety. So a little bit about UL, what UL does. UL is a leading global organization whose mission is dedicated to the advancement of safety science research and standards development. Simply stated, we write standards that the manufacturers have to comply with if they want to sell products in the US. Those standards describe what the construction ought to be to create a safe product. At the core of our mission, the tenet of our mission, is working for a safer world. And it's important, at least for me, it's important to work in a company whose mission is values-based. Because if you do that, then your job doesn't feel like work anymore. And I've been there 15 years and it's gone by like that. Another way to put this is safety engineers try to make a positive difference in the world. And it's important to make a positive difference in the world. Medical personnel like doctors, they devote their careers to healing people after injury has happened, getting them better. Safety engineers try to anticipate the risks that cause injury or harm and try to come up with ways to mitigate that risk, to reduce it. You can think of this as two opposite ends of the same spectrum. So, why safety? I'll give you an example. If you recognize that thing up there, it's a hoverboard. The hoverboard was introduced in the market around 2015 or so. And up until UL stepped up to write a safety standard to describe its construction, how it ought to be, the hoverboard was responsible for over 250 fires in the United States, 13 grave injuries, and unfortunately 2 deaths. Keeping unsafe products from the market is an obligation. People have a fundamental right to exist in a safe environment, whether that's at your house or at work. You see, manufacturers don't always know how to build a safe product. Their priorities usually lie with making a profit. There needs to be someone to draw a line in the sand that separates excess profits from manufacturers from health and well-being. And that's what UL does. Another way to think about this too is innovation, especially since the advent of the computer and the widespread use of the computer and everything that comes with it. Innovation often tends to outpace the ability to create safe products. Innovation sometimes needs to be checked. I'll give you an example of what I'm talking about. Suppose you're one of those people, like myself, who enjoys controlling everything from their smartphone. It's nice to be able to control the temperature in your house, or the lighting, or opening up the garage door. Many, many things you can do with your smartphone. If you look into modern kitchens, most devices now are smart enabled, or they have communication means to a smartphone or computers, right? But should people be given free rein to do anything they want? For example, should you be able to turn on your oven from your smartphone? Well, not so fast. I realize it would be convenient to be able to turn on your oven while you're still shopping at the store, so you can have an oven that's preheated when you get home to start cooking dinner. But what if you stored something in there that you forgot about, and you turned on the oven when you're half an hour away from your house or more, and you can cause a fire? Or what if you're at the store and your kid has opened up the oven and the cat jumped in, and now you're turning it on from a distance? People have to be provided with a measure of safety, even when they don't know what can go wrong themselves. Staying with the oven example, as you may know, carbon monoxide, that's an odorless, colorless gas that can kill you in minutes. In general, whenever you have a flame that hits a metal surface, you get the potential of forming carbon monoxide. Any gas appliance can do this. What we do at UL is we test those products. We look at their construction. we make sure that nothing bad like that can happen. So whenever you're faced with a choice to buy something for your house, whether it's electric, gas, or whatever, please make sure that you're looking for a safety label. Okay, that's going to give you a measure of assurance that the risk of something bad happening is minimized. Let's do a couple more examples. This clipping is from the New York Times. I believe it's from 1978, showing a hair dryer. Until a safety standard was written for hair dryers, they were dangerous little devices. People got electrocuted to death, either by having a faulty unit, they're stepping in a puddle of water, they're holding this thing, electrocuted themselves, or I even read stories about how the hair dryer fell in a bathtub while somebody was taking a bath. This is one of my favorite little clips. It's from Mythbusters. I used to watch the show a lot when I was younger. It shows what happens when 50 gallons of water turn into steam all at once. And that's what a water heater is. It's a device specifically designed to make really hot water. Unless safeties are put on these devices, things like that could happen. Both the examples that I mentioned for a reason, because I want to point your direction to a concept that's fundamental to safety engineering, and that's called redundant safety. Redundant safety simply means having more than one barriers to protect against injury or death. So in the case of, let's say, the hair dryer, those hair dryers are typically made out of plastic, for example. That's not just a cost-saving measure. Plastic is used because plastic is a barrier against it does not allow electricity to go through. That's barrier number one. Even if that fails, if you've noticed, there's a little black box at the end of the cord. That's called a ground fault circuit interrupter, or GFCI for short. What that little black box does is it senses if electricity is going anywhere but where it's supposed to go. So electricity is supposed to go into the heating element, into the fan. If it goes anywhere else in your body, for example, it senses that and it kills power. We were talking about an oven before, right? If you notice, if you have a gas cooked up at home and you want to turn it on, first you have to push the knob before you can turn it. It's designed that way to prevent accidental turning. Even if you somehow manage to turn it accidentally, odorants are put in the gas, the natural gas, that gives it the characteristic smell. Those are called mercaptans. That's there as a second barrier against injury, or in this case, explosion. I wanted to give you one final example that also deals with safety, but in a slightly different way. Something more contemporary. I'm sure you've heard about this for the last year and a half on the news. It's everywhere. It has to do with the COVID-19 vaccine. Vaccines against COVID are a true testament to STEM. It represents the effort of thousands of medical personnel, doctors, engineers, scientists, to be able to develop not just one, but 3 vaccines in the United States. That's remarkable. But developing the vaccine is only step 1. Some of these vaccines have to be kept at a really cold temperature. Specifically, the Pfizer one has to be kept at -70 degrees Celsius. That's colder than Antarctica. How do you do that? How do you get a vaccine from the manufacturing plant to the entire nation and abroad when it has to be kept at that cold of a temperature? Well, you do that by using units such as this, a medical freezer, okay? And hospitals have these, pharmacies have these. But the problem is, these units were never designed to reliably maintain a vaccine at -70 degrees Celsius with a very high amount of sensitivity to temperature changes. Some of the older units suffered from having hot spots. You know, like the right side of the oven is hotter than the left side of the freezer, I'm sorry. The right side of the freezer being colder than the left side of the freezer. Top to bottom, temperature gradients. Even the seal around the door, you know, it can leak. Things like that cause uncertainty to the people administering these vaccines? Is what you're putting in the other person's arm actually going to work? Has that shot lost its efficacy, as it's called, or its ability to work? Has it lost its efficacy as a result of not being stored properly, not being transported properly? It wasn't long into the pandemic when the CDC approached the regulatory industry, including UL, asking for a solution to this problem. And I was part of this effort, and I'm very proud of that. But the solution to this problem ended up being a new standard, a standard specifically designed for medical freezers, that once a manufacturer was able to certify their freezer to this new standard, then whoever's buying that freezer can be sure that whatever they're storing in their vaccines stays at the exact temperature that it needs to be to maintain its efficacy. Risk mitigation, safety, sustainability is what motivates me to get up every morning and go to work. I know people think of engineers as people who design airplanes and cars and use cell phones, and that's great, that's needed, but that's not who I am. Thank you for this time, and have a good day.